We will start now with the second section of this chapter, which is chemical equations. So, what are chemical equations? In any reaction, we are interested in the substances we start with, and those are called the reactants, and the new substances produced, which are called the products. So we have the reactants and the products. The reactants are those substances that the reaction starts with, while the products are the substances that we have when the reaction is over. So a chemical equation shows reactants and the products. So if we look at chemical equations, we will be able to know what are the reactants and to identify the products. Let's move to what is called word equation. A word equation shows the names of the reactants and the products. For example, this is the word equation for the test for hydrogen gas. So we have hydrogen and oxygen, which gives water. Hydrogen and oxygen are the reactants and water is the product. So at the beginning of the reaction, we will start with the two elements, hydrogen and oxygen, and when the reaction is over, we will have water, which is the product. Another kind of equations is called symbol equations. To show how much of each substance is involved in a reaction, we use symbol equations. So as you can see here, we will write the symbols of the reactants and the products and not their names. For example, we have here CH4 and O2, which are the reactants, and the products are CO2 and H2O. In the previous example, we wrote oxygen and water. However, in the symbol equation, we will write their symbols. The symbol equation of the decomposition, which means breaking down of calcium carbonate, which is CaCO3, is as follows. So we have CaCO3, which will give CaO and CO2. As you can see, what is written in this equation are the symbols of the reactants and the products. The reactant in this reaction is CaCO3, while the products are CaO and CO2. Let's count the number of each type of atoms on both sides to check if this equation is balanced. If the numbers are equal, then it will be balanced. So in the reactant side, we have one calcium atom, one carbon atom, and three oxygen atoms, while in the product side, we have one calcium atom, one carbon atom, and three oxygen atoms in total. So on both sides of the equation, there's the same number of each type of atoms, and then it is balanced. This shows actually that atoms cannot be created or destroyed in a chemical reaction, and this can be restated as follows. The total mass of the products formed in a reaction is equal to the total mass of the reactants, and this is actually called the law of conservation of mass. You will have to pay attention to one point. This law may seem to be broken in reactions involving gases which are conducted in open containers. For example, in this reaction, you will find that the mass of calcium carbonate, which is CaCO3, has decreased after heating it. And the reason behind this decrease in mass is that CO2 gas, carbon dioxide, produced has escaped into the air. Now we will look at state symbols. So what are state symbols and why do we use them? We can add state symbols to describe precisely the reaction. These state symbols shows the states of the reactants and the products in a reaction, and they are S for solid, L for liquid, and G for gases. A fourth special state symbol is AQ, which is used for substances which are dissolved in water, and these are called aqueous solutions. So if we want to write the previous reaction with the state symbols, we will write the following: CaCO3 S, and in the product side we have CaOS and CO2 G. This means that CaCO3 and CaO are in the solid state, while CO2 is in the gaseous state.